Welcome, everybody. Thank you for being here. My name is Sushmita. Today, we will be discussing Advanced Weather Forecasting System project. Please hold off your questions till the end. Today, I will be presenting my project plan for the AWFS project. This project was developed with the goal of delivering accurate and real-time weather forecasting using modern technologies like IoT, machine learning, and cloud computing, supported by robust project management practices. Project description is includes what the project describes. The AWFS will collect all the data from multiple sources like satellites, ground-based IoT sensors, and weather stations, and the use of machine learning models to analyze patterns and generate real-time predictive forecasts. These forecasts will not only support individual users but also critical sectors such as agriculture, aviation, where decisions heavily depend on the weather. Our project scope covers end-to-end weather data management, from gathering raw data to transforming it into actionable forecasts accessible via mobile application and APIs. Additionally, geographic mapping will help users visualize weather conditions spatially, which is particularly helpful for logistics and emergency management sectors. In assumptions and constraints, we will assume that the sufficient historical and real time data will be available. We also assume that there will be compliance with the local national regulations. Constraints include our system's focus on a specific geographic region and use of already installed weather stations without manufacturing new hardware. Our project team members and stakeholders include project owner, manager, infrastructure engineer, lead data scientist, software engineers, IoT engineers, GIS specialists, QA engineers, data providers, government and regulatory bodies, and end user. The project team includes diverse technical and managerial roles. Beyond the internal team, our stakeholders are critical. Data providers ensure input data quality, regulatory bodies guarantee compliance, and end users ultimately validate the system's effectiveness. Each milestone marks a major achievement and decision point for the project. Together, these milestones ensure systematic progress and well organized development lifecycle. Milestone 1 includes initiation and planning activities. This phase ensures clarity of purpose, identifies risks early, and sets a realistic, well supported plan. It ensures all stakeholders are aligned and expectations are formally documented. Milestone 2, system architecture and design activities. This technical blueprint forms the backbone of AWFS. A solid system design ensures the future development, integration, scaling happening smoothly and securely. Milestone 3, model development and data integration activities. The intelligence of AWFS depends on its ability to process and learn from huge data sets. This phase guarantees that the forecasting model is accurate, robust, and reliable. Milestone 4 includes software development and implementation activities. Software engineering ensures that the users can actually interact with the system easily. Backend, frontend, and integration work together to ensure seamless performance and scalability. Milestone 5 includes testing, deployment, and launch activities. Testing is essential to ensure quality. Launch activities focus not just on deploying a working product, but also on ensuring users are well trained and confident in its use. Milestone 6, the project closeout activities. The project closeout finalizes all the work. Lessons learned are documented to improve future projects. Team and resources are released formally to close financials and commitments. This is our WBS chart for our AWFS system. A structured work breakdown, structure breakdown. breaks down the project into digestible parts. It provides clarity, improves delegation, and strengthens accountability. Here we have four levels. The first level is our software development. Second level is our planning and preparation, development and integration, testing and deployment, and project closeout. Level 3 includes sub activities for planning and preparation, development and integration, testing and deployment, and project closeout. Sorry about that. This is our Gantt chart. The Gantt chart provides a visual tracking method, helping project managers oversee timelines, spot dependencies, and proactively manage bottlenecks. The Gantt chart is a visual timeline of the project. It shows the start and the end dates of all project tasks. Milestone and activities are broken down into sequences. Tasks are laid out horizontally so you can easily see dependencies and overlaps. It helps the project track progress and monitor deadlines at a glance. Each milestone, like initiation, architecture design, model development, testing, and closeout, is clearly represented. Activities inside each milestone are tracked so that even smaller delays can be detected early. The project closeout phase is included ensuring the project is properly finalized. Dependencies between tasks like needing to complete backend development before API integration are clearly shown. The Gantt chart helps resource allocation, it helps the team understand the priorities, it allows early detection of potential delays and risks. Critical path analysis of AWFS is here. As you can see, all the five phases are shown. The critical path management ensures that any delay in key task is immediately addressed. Knowing the critical path helps prioritize, safeguard our project deadlines. These tasks are sequential and interdependent. For example, you can't start API integration until backend development is done. We focused management attention and resources on these tasks to minimize the risks to schedule overruns. This key strategy for AWFS is we closely monitor the backend development and testing phases because they are technically heavy lift areas. We build some slack to non-critical tasks like front-end UX polishing so that if delays occurred outside of the critical path, the project overall would not suffer. The PERT analysis improves the forecasting accuracy by considering the best case and the worst case scenarios, helping to manage stakeholder expectations more realistically. The PERT stands for Program Evaluation and Review Technique. It used the estimate project by considering uncertainty. Instead of assuming one single task duration, PERT uses three estimates: optimistic, most likely, and pessimistic. Our optimistic is the best case scenario, most likely is normal scenario, and pessimistic is the worst case scenario. The formula for PERT is the optimistic plus 4 times most likely plus the pessimistic divided by 6 gives you the PERT. PERT improves the forecasting accuracy. It helps managing uncertainty better than traditional single duration scheduling. It helps trust with stakeholders by showing that risks are being considered in planning. As you can see, there are five phases in my PERT analysis. We have initiation, planning, execution, control, and closeout. Now, all these phases have their milestones and activities, including the optimistic, most likely, and pessimistic days allocated to them, and the PERT calculated for each activity. Next is monitoring and controlling. Monitoring and controlling are not one-time activities. They are continuous, ensuring project stays within its planned boundaries and responding quickly to changes. So we regularly track the progresses using the Gantt and the PERT analysis. We also immediately use corrective actions if delays are found. We focus on communication and early risk management. To conclude, strong planning, critical path management, and responsive controls will help AWFS meet its scope, time, and quality goals. providing real value to its users. These are my references, and thank you for listening.